Hello everyone. In this session, now we will see the next two improvements which are done in standard or traditional TCP for supporting mobility in the mobile networks. Okay, these are snooping TCP and mobile TCP. So let's look at the snooping TCP first. Now, whatever drawbacks that we have seen in the indirect TCP, we are trying to overcome that in this particular type of enhancement. So the snooping TCP is a transparent extension of TCP within the foreign agent. Now what does that mean? Now in the indirect TCP, we have seen that foreign agent divides the standard TCP connection into two parts. Okay, this is our foreign agent. Now this is our traditional TCP, that is standard TCP, and this is wireless TCP. Now this is the scenario for indirect TCP. So connection is broken, end-to-end semantics are broken. So whatever happens in the wireless path, correspondent node is not aware about that. So it is non-transparent modification of the original TCP. Correspondent node does not know whether packets are really received by the mobile node or not, because foreign agent sends the acknowledgement back to the correspondent node. Okay, so that is non-transparent. Now transparent extension means now all the tasks which were done by foreign agent in the indirect TCP, those will be changed. A foreign agent no longer will send the acknowledgement. Also, it will not break the connection as happened in the indirect TCP. So, what are the factors of a transparent extension? First of all, foreign agent will buffer the packets which are sent by the correspondent node to mobile host. Okay, so all the transmission that is done by correspondent node will be buffered at the foreign agent. Then lost packets on the wireless link in the both direction towards the mobile host and from the mobile host will be retransmitted immediately by the mobile host or foreign agent respectively. So for example, if this is foreign agent and data is to be delivered to mobile host, and because of wireless problems, that is whatever interferences that we occur, if packet is not delivered, correspondent node will not retransmit the packet, foreign agent will retransmit the packet. So that is called as local retransmission. So the delay is less. Okay, but loss of packet may be known to the correspondent node. Okay, so that's why it is transparent. Then third one, the foreign agent therefore is called to be snooping the packet flow and recognizing the acknowledgements in both direction. It also filters the acknowledgements which are duplicated in this case. Sometimes because of certain delay, same acknowledgement is sent twice. Okay, so that is also filtered out by the foreign agent. So snooping, word snoop means buffering the data or secretively copying the data without interrupting the actual transmission or without interrupting the actual communication. So the changes of TCP are only within the foreign agent. Correspondent node or mobile host or mobile node both doesn't have to change anything. The changes has to be within the foreign agent, which will be in between both of them. Okay, so let's see working of that. Now this is the scenario. You can see correspondent host here. Now it is initiating a transmission because we are considering the first case, data transfer to the mobile host from correspondent host. Host and node both are one and same thing. Now the packets travel through entire wired internet, reaches the foreign agent. A foreign agent buffers the data, buffers these packets and allows it to go towards the mobile host. Okay, so connection is not broken by the foreign agent. Okay, FA buffers the data until it receives the acknowledgement of the MH. Now if packets are received by the mobile host, it will send a acknowledgement back to foreign agent. Now if acknowledgement is not sent, FA detects the packet loss via timeout or sometimes duplicate acknowledgements also. Okay, same acknowledgement received for one packet, more than one acknowledgement received for more than one packet. So that is duplicate acknowledgement. So FA will detect there is a packet loss. Now in case of packet loss, correspondent host does not retransmit the data. Retransmission is not done by the correspondent host. Now retransmission is done by the foreign agent itself. Okay, that happens in case of the packet loss. So that is called as local retransmission. Here you can see that. Okay, so that's why it is called as fast retransmission possible, and it is transparent for the fixed network. Now local retransmission done by foreign agent is also known to the correspondent host. So correspondent host can see that foreign agent has retransmitted the lost packet. So everything is transparent for the correspondent host. Okay, so what are the differences? First difference is that foreign agent does not break any kind of TCP connection, that is end-to-end TCP connection is maintained. Second difference is that lost packets are retransmitted by the foreign agent called as a local retransmission. Okay, and third, correspondent node is aware of all the activity done by the foreign agent, so that is transparent connection. Now let's look at the scenario in the reverse direction. So data transfer from the mobile host. So this is now a transmitter and this is now a receiver. Now mobile host has started the transmitting packets. If it detects a packet loss on the wireless link via sequence number, okay, because every as you know, in the standard TCP header there is a sequence number which tells receiver about order of packets. So foreign agent will know any missing sequence number and detect it as a packet loss. Okay, FA answers directly with negative acknowledgement to the mobile host. Now in this case, foreign agent does not have any buffered data. Packet loss has happened here itself in the forward direction. Okay, so packet is lost in the forward direction, no buffered data. So what foreign agent can do? It sends a negative acknowledgement in the negative reverse direction to the mobile host. Now from this negative acknowledgement, mobile host retransmits the data with very short delay. Okay, after successfully receiving the packet, foreign agent forwards the packet to the correspondent host and then acknowledgement is sent by the correspondent host. So negative acknowledgement is sent by foreign agent, but acknowledgement is actually sent by the correspondent host. Okay, so that's how it works in case of snooping TCP. It is very advantageous. So let's say see the advantages of this. First advantage, end-to-end TCP semantic is preserved. That means TCP connection, which is considered to be end-to-end, that means transmitter to receiver, is not broken, so that semantic is preserved. The approach automatically falls back to the standard TCP if enhancements stop working. Okay, so if these modifications do not work, then we will follow with the traditional TCP that is used in the wired networks. Okay, second advantage, correspondent host does not need to be changed. There are no changes required in correspondent host because everything is handled by foreign agent in case of packet loss, and most of the enhancements are in the foreign agent. It is said that most of the enhancement are in foreign agent because there are some enhancement required in the mobile host, but most of them are in the foreign agent. Okay, when a mobile host changes the foreign agent, as in the indirect TCP, let's say mobile host initially was connected to foreign agent 1, now it has moved to some other foreign agent, let's say foreign agent 2. That means in indirect TCP, we have to transfer the socket, transfer the state, transfer the buffer. All these things had to be done in the indirect TCP. There is no need of that in case of snooping TCP. Okay, so no need of handover of state as soon as mobile host moves to the another foreign agent, because TCP connection is not broken, so there is no state, there is no requirement of socket because TCP connection is created by correspondent host. So correspondent host knows the socket. Foreign agent is unaware of the socket. Socket means IP plus port number. So no state transfer or no socket transfer in case of snooping TCP. Okay, so that is the another advantage. Then next advantage is that it does not matter if the foreign agent uses enhancement or not. Okay, that is next foreign agent. So after moving to a new foreign agent, it does not matter if the next foreign agent uses enhancement or not. Okay, why? Because if it is not supporting the mobile snooping TCP, then approach will automatically falls back to the traditional TCP solution. Okay, so it is not necessary all foreign agents should be supporting mobility. If they are not, then you can use the traditional TCP, of course with the disadvantages that it comes along with. Okay, but the transmission will not stop completely. Okay, so these are the advantages. Now let's see what are the disadvantages. Snooping TCP does not isolate the wireless link as good as ITCP. Now what's the meaning of isolating wireless link as good as ITCP? It means that the problems on the wireless link are also visible to the correspondent host. If packet loss is there, okay, that's foreign agent is retransmitting the packets locally, but it is visible to the correspondent host. So it is not fully isolated. So correspondent host may or may not change its behavior regarding transmission of packets. Okay, so that can impact on the performance of a TCP. Second disadvantage, negative acknowledgements between foreign agent and the mobile host. We saw that when mobile host is a transmitter, if packet loss is there, foreign agent sends a negative acknowledgement to the mobile host. It means that it assumes that additional mechanisms are required at the mobile host. We have seen this in the advantages part also. Most of the changes should be done in the foreign agent, but some changes are required in the mobile host as well. Mobile host must support the negative acknowledgement mechanism, otherwise snooping TCP fails to work. This approach is no longer transparent for arbitrary mobile host. So sorry, negative acknowledgement are not always supported by any arbitrary mobile host. So this may not work in case of all the mobile hosts. So that is the second disadvantage. Then third disadvantage, snooping TCP might be useless depending on encryption schemes. Now recall what is the exact mechanism. Foreign agent is buffering the data which is coming from correspondent node. It is only buffering the data, that means copying the data. It doesn't know what the data is. Usually in the TCP header there is a mechanism called as a checksum, which is used for error detection. Similarly, if correspondent node is using any encryption scheme like IP encapsulation security, or that is called as IPsec, or higher layer encryption schemes like SSL or TLS, secure socket layer, or uh, transport layer security. If data is encrypted, that is the uh, summary of what we are saying. If sender is using a encryption scheme, then there is no use of buffering this data, because foreign agent now will no longer be able to retransmit the missing packets. Let's see why. Because let's say packet loss is there on the wireless part. This is mobile node and this is foreign agent. Okay, and packet is lost. Now to retransmit the packet, foreign agent must know which packet is lost. Okay, that will be identified via sequence number. A sequence number tells which packet is lost, and that packet will be retransmitted by the foreign agent. But since the encryption scheme is used, entire header will be encrypted. So foreign agent will never know what is the sequence number that is missing from the communication. So because of encryption, TCP header is not understandable by the foreign agent and it will not be able to retransmit the packets. and most of the modern day communication use the encryption scheme for communication. So in that case, something more needs to be added in the snooping TCP. Okay, so these are the disadvantages of the snooping TCP. We have seen advantages, disadvantages for both ITCP and snooping TCP. Both have some drawbacks, some advantages. So what we can do is combine both of them and generate a new version or new improvement in the traditional TCP, that is called as now mobile TCP, or it is also known as MTCP. Okay, MTCP is used for special handling of lengthy or frequent disconnections. Now what is MTCP doing? MTCP is combining advantages of both ITCP and snooping TCP and trying to overcome disadvantages of both ITCP and snooping TCP. So what MTCP does? First thing it does, sorry, first thing it does is that it splits the TCP into two parts, similar to ITCP does. Okay, so again, foreign agent will split the connection into two parts. One is wireless, sorry, it will be wireless, and another is wired. Okay, this is mobile node and this is correspondent node. So this is wireless, this is wired. Unmodified TCP is used in the fixed network, that is up to the supervisor host. Now this foreign agent is known as supervisor host. This is our standard TCP. Because TCP is now broken, no need to change in the wired network, standard TCP can be followed. Okay, and in the wireless part, optimized TCP is used for SH to MH. So here optimized TCP is used for SH to MH. Now this node is called as supervisory host. Now difference between supervisory host and foreign agent in the previous versions is that supervisory host does not do any buffering of data, no caching and no retransmission. Any lost packet will not be locally retransmitted by the supervisory host. So supervisory host is just observing the communication. It is not buffering or copying the data, or it is not acting on loss of data. Okay, then what is the job of supervisory host? It monitors all packets, that is all communication is monitored by it. Then if disconnection is detected, what supervisory host does that it sets the sender window size to 0. So let's say supervisory host observes a break in connection. So what it tells the correspondent host to reduce his TCP window size, transmission window size to 0. Now setting the window size to 0 means that correspondent host should pause the transmission, not stop the transmission. Okay, pausing the transmission will help in eliminating the disconnection. As soon as there is a connection detected, again window size will be increased. Okay, so whenever disconnection is detected by the supervisory host, it sets the window size, sender window size to 0, that pauses the transmission and automatically goes into the persistent mode. So correspondent node is said to be entering into persistent mode in case of window size to be 0. Persistent mode means it is able to transmit, but it is momentarily stop transmission because of disconnection at the wireless part. Again, a retransmission will be done by correspondent host. Then acknowledgements will also be sent by the mobile host to the correspondent host, or correspondent host to the mobile host. So end-to-end semantic, although it is not maintained, somehow the phenomena will be maintained by the mobile TCP. Okay, and when mobile host moves to the new network, a new supervisory host will reopen the window. Okay, so old or new supervisory host will reopen the window. So that can happen. This disconnection is possible in case of changes of the network, and in that case new supervisory host will reopen the window. That is what it is said. Okay, so we are trying to combine whatever advantages of ITCP and snooping TCP in this case. Okay, similar to ITCP, we are breaking the connection so that performance can be improved, but at the same time we are not buffering the data, to avoid loss of or loss of performance in case of if correspondent host is using any encryption scheme. So if it is using any encryption scheme, then supervisory host will not have to act upon it or will not be able to responsible for uh, not providing the solution, because correspondent host will retransmit the packets. Okay, so let's see what are the advantages and disadvantages. It maintains the TCP end-to-end semantics, because even though the connection is broken between correspondent host and mobile host, the acknowledgements are sent by mobile host or correspondent host. Also, retransmission is done by the transmitter and receiver host. Foreign agent, which is called as supervisory host, does not do anything in between. The supervisory host does not send any acknowledgement itself, but forwards the acknowledgement from the image. It does not send, it does not copy anything, it just forwards the data from sender to receiver. If mobile host is disconnected, it avoids useless retransmission and slow starts or breaking the connection by simply shrinking the sender window size to 0. That is advantage. So sometimes in case of ITCP or MTCP, is connection is terminated and the wireless part, uh, retransmission will be useless and avoid providing network congestion in the wireless part. So that is avoided by shrinking the sender's window size to 0. That will pause the transmission. Okay, since it does not buffer the data, that is the two advantages done. It is does not buffer the data in the supervisory host as ITCP does or Snooping TCP does. So it is not necessary to forward buffers to new SH. ITCP requires transfer of state as well as socket to new foreign agent. That is not required here because no data has been copied by the supervisory host. Lost packets will be automatically retransmitted to the new SH by the correspondent host. Now it's the responsibility of sender to retransmit the packets. So no transfer of state or transfer of socket is required in this MTCP. So these are some of the advantages. Now what are the disadvantages? One of the major disadvantage, packet loss on wireless link is visible to the fixed network. So packet loss is propagated into the fixed network because supervisory host is not retransmitting the data or it is not hiding anything from this correspondent host. That's why packet loss will be propagated into fixed network. So correspondent host behavior may change and it should change. Sometimes not required, the changes are not required, but still it will happen because of correspondent node being aware of packet loss at the wireless part. Okay. Second disadvantage, a modified TCP on the wireless link only requires modification to the mobile host protocol software. So not only requires modifications to the mobile node but also requires network elements like bandwidth manager. Okay, shrinking the window size to 0 or it is getting increased, that requires a special software, and that bandwidth manager may be required at the mobile host also, because uh, every communication is handled by transmitter and receiver. Supervisory host is not taking any responsibility, so additional protocol softwares may be required at the mobile host. So that is the another disadvantage. Okay, so till now we have seen three modifications to the traditional TCP in order to support mobility. All of them have certain advantages, certain disadvantages. Depending on scenario, we can use any one of them at the transport layer. There are furthermore two types that we will see in the video, next video, and after that we will see the comparative study of all the modifications done to the traditional TCP. That's all for today. Thank you.